Hi, I'm Abby Brown, and we're here at the Wolfram Technology Conference. These are a few of my students.
Hi, my name is Emily Zhang.
Hi, I'm Shannon Brownlee.
We're from Torrey Pines High School in San Diego, California, and we're going to be talking about our new club that's about computational thinking, CT at TP. I'm Abby Brown, and these are my students, Shannon and Emily, who will be presenting here with us as we talk about our high school computational thinking club. You want to go ahead and take care of it? So a little bit about me. My name's Abby Brown, as I said, and I teach at Torrey Pines High School in San Diego, California. I've been a Mathematica user since 1992 when I was in college, and I've been teaching since 1996. And for much of my career, I've been using Mathematica with my high school students. I recently started a computational thinking club at the high school, and this is what we wanted to share with you today. Emily and Shannon are students who were in my calculus classes last year. They participated in a summer training program using the Wolfram language with Augment software, and now they are leaders within the club for other students. We have two other related presentations at the conference. Following this talk, Ryan Hio and Likith Palamandela will be talking about their Wolfram summer camp experiences. They are my students. And Isaac Gelman, who is a graduate who worked with me the last couple of years, will be speaking with Eric Nelson about the Augment software training this afternoon at 4:30 in this room. Throughout the presentation, there are images with the slides that come from different activities that we've developed for the club. And I could give a 20-minute talk on each one of those images and where it comes from and how we put that together. So I'll try to hold back a little bit, but if I remember, I'll mention something about each one. So this one, the idea was an activity to create a word cloud based on a favorite song. So students would find lyrics and then find a related image and then put it all together so the word cloud would wrap around that image. Oops. So why am I doing a club? Like, where is this all coming from? So my driving question in this was I wanted to find a way to reach students who were not in my current classes and introduce them to the Wolfram language. There's so many more students at the high school who could be interested in this. How can I start showing them what we can do? And what really inspired me to do this was after a few years when I was unable to come to the Wolfram Technology Conference, I returned in 2016 and learned a lot more about the kind of new features of the Wolfram language, the stuff with image processing and geodata and all this stuff that was like way beyond just graphing curves and equations and solving algebra problems, which was kind of our primary focus with Mathematica. I also was a little selfishly motivated. I primarily teach juniors and seniors, and I thought, wouldn't it be amazing if the students came into my classes having some Wolfram language experience rather than waiting until they're a senior and saying, hi, here's some great program, and then they leave. And that's great that they take that knowledge with them, but I think how much more could we do if there was more experience coming into my classes? One of the obstacles to that goal, however, has been working with other teachers at my site. I'm kind of the lone wolf in using the Wolfram language. A lot of the other teachers always say, hey, that's cool, that's interesting, or maybe I help them make a graph or something, but they just don't have time to really delve into it. And of course, there's also now so many free online resources that seem easier to use to just get results that they need immediately in their classroom. Just go ahead and page down or click over, yeah. So 2016 is when I had kind of the first inspiration, like, let's do this. And what we started was what we called the Wolfram language workshops. And a couple students were excited by this, about this idea. We created these posters that were all mysterious and just hung them up all over campus and to see who would show up and learn like what this is all about. And we had several students that were interested. I tried to keep things kind of informal. I didn't want this to become like this huge obligation on top of everything else we have going on. So I figured let's meet just a couple times a month. Like sometimes we met on a Tuesday, sometimes we met on a Thursday. And I wanted to try using the Elementary Introduction to the Wolfram Language, EWIL, as just sort of a guide. Like, hey, let's just work through these problems and exercises and do this. Well, there were some challenges to this that ultimately led to the failure of the Wolfram language workshops. And one of the most immediate issues was the lack of a regular schedule. The students are very busy, and having something that just met sporadically, it was hard to get students to like, oh, well, I can't come this time, or that day doesn't work for me. And so it just fizzled out pretty quickly with maintaining student interest and ability to come. I also didn't want it to be another class for me to prep. And that was something I was really trying to avoid. Like now I'm writing new lessons and doing all this when I'm already doing that for 3 other courses. The student leaders that were so excited with me caught a real early case of senioritis as well. And senioritis is real. I live it. And it didn't help either because it all sort of fell onto my shoulders and it just kind of fell apart. The other thing that came up was the EWIL book didn't work very well as our sole resource. What I found was a lot of these little neat examples, but the students kind of lost motivation and interest because they didn't really get to see in that alone where it all could lead. Like, how do I put this together to do something really great? It's like, well, this is this nice little thing, this is this nice little thing, but like, what am I doing with this? So I came back to the conference last year and found a new inspiration. Really a big theme throughout the conference last year was this idea of computational thinking and computational essays. And I realized that that's more my theme. It's rather than focusing on like, oh, we're gonna learn this programming language, like let's do computational thinking. And I thought this might be a new way to sort of tap into things with the club. I also connected with the computational thinking initiatives and learned about some of the resources that they have available to share in the type of environment that I'm working with. I also committed to a new structure. I said, we've got to do this weekly or it's not going to happen based on the experience of the previous year. And so what we did was we pretty much always met on the same day, but occasionally I'd sprinkle in a different day because there would be maybe people who couldn't always do Mondays. And I didn't make every week like a lesson. So some things were like activity days, some days were explore days. So it wasn't so much that I had to like prep for it and create all these lessons. I also had new student leaders who were really excited and committed, and we spent more time with those leaders forming a vision for the club before we actually launched it. Those student leaders were able to create some of their own activities, they led activities, and they supported new students who came in throughout. So we might have some brand new student, and they could sit with them on the side and help them get started while we could continue on with our activities. Activities were created by me. We could use some of the AI adventures from the computational thinking initiatives. And so like I said, some of my students created some activities of their own. We also had sometimes during our Explore days what I like to call computational thinking conversations. A student would ask a question and we'd just start coding and trying to see if we could solve this question, kind of like a live coding experience on our computer screen. And I've saved some of those and put them on our website. We've talked about topics such as machine learning, image processing, interactive animations with Manipulate, text analysis, and some 3D printing. Which reminds me that the prints are getting passed around. So if you haven't seen them yet, you can continue to pass those around. So we had success from last year. The student attendance increased, and they really seemed to enjoy the different activities. Some were using Mathematica and the Wolfram language to do stuff for their math classes, and a few students really did a lot and got really involved and spent a lot of time with the EWIL book and got into their own projects. In particular, 3 students, Ryan and Licketh, who were presenting after me, and a third student, Spencer, decided to do a machine learning project. And at the time, these were students who were not in my current classes. So they were taking the class that leads into mine, and their only mathematics experience had been through the club. And they did a project that they'll talk a little bit about later. And then Ryan and Licketh attended the Wolfram summer camp from that experience. And now all 3 of the boys are part of the leadership team within our club. Also, my selfish goal got somewhat realized as well, because I do now have students who are in my calculus classes who got a little more Wolfram language experience before we started things off. And I have students taking my projects-based class, which is all about the Wolfram language and Mathematica, who probably wouldn't have otherwise been there because they had been inspired through the work with the club. So I'm going to turn it over to Emily, who will talk about some of her experiences.
All right. Hi, everyone. My name is Emily Zhang, and I'm excited to share some of my experiences using Mathematica. All right, so my first exposure in using Mathematica was through Miss Brown's calculus class, and it was very helpful to be able to visualize a lot of the different math concepts. And other than being part of the Computational Thinking Math Club, another great experience that I had was through doing the final project, end of the year final project for my calculus class. And I wanted to incorporate something related to triple integrals. So I used a book problem, as you can see on the board. So that problem, it was a very interesting problem, asking me to find how much work it would take to form a mountain, or specifically Mount Fuji. And so all was well. I used triple integrals and I solved the problem. But I wanted to be able to have the listeners be able to visualize this problem. And so I was curious about how could I use computational thinking to model a mountain. And so with Miss Brown's guidance, I was able to create that one line of code. So we were able to model a mountain using data from an image. And so as you can see in the top left corner, you can see this a little white circle over there, and that's Mount St. Helens. And then if you can scroll down, so I cropped the image, and I was able to find the contour plot, and if you can scroll down, you can see I created a 3D model of the mountain based on data from an image. And so Ms. Brown said there was probably another way to do this. And so I was curious, and I searched through Wolfram Documentation Center, and I came up with another method. And this method was I could create this 3D model using just data directly from Mount Everest. And if you can see, that is a model, 3D model of Mount Everest. Cool. All right, and if you can scroll down. And so I was curious, I wanted to bring in some more concepts that I learned in calculus class, which is contours. And so I creatively was able to create this contour plot using this infinite viewpoint thing. It was very interesting. Okay, and so now with these cool functions in hand, I was able to go back to my original problem, which I was able to create this 3D model of Mount Fuji and a contour of Mount Fuji. And if you can see it, it's actually not really a contour, it's a 3D thing, but we were able to creatively do it using infinite viewpoint function. All right, so one thing I really like about using computational thinking is where one exploration leads to another, and we didn't just stop here. I was curious on how I could model these mountains using 3D, using a 3D printer, and then we have 3D prints floating around here. Yeah, and so one thing that's really great about this is that we're able to use these 3D models and their contours in Ms. Brown's class when she teaches calculus. And I'm also planning on creating a lesson plan teaching students about modeling mountains and other geofunctions in Computational Thinking Club. And so now Shannon will present some of her experiences using Mathematica.
Okay. Hi. Oops. Click over. Yeah. Well, hello, I'm Shannon. I'm a senior in Miss Brown's Advanced Topics Projects class right now. And I took her calculus classes last year. I was first exposed to coding my freshman year when I tried to join Girls Who Code at my school. And after a few meetings, I just really got bored of it. We did Java. It just didn't quite make sense to me. It didn't really click. And so I kind of gave up on coding for a while. And then my junior year in Miss Brown's calculus class, she started using Mathematica. And with that, we would do manipulates to model things we were learning, so like infinite series or quadratic surfaces, things like that. And it really helped to learn all kinds of abstract ideas just by seeing like, oh, here's what happens when you change different variables. Here's what happens if you rotate it. It was a super helpful tool for a lot of us in the class, especially since we're very visual learners. And so going into that, when we started to do more projects into it and she started her Computational Thinking Club, I thought it would be a great place to learn a little bit more about coding and maybe try and get into it again. And so I went to a few meetings and I thought it was such an interesting idea and a very cool language to learn, especially in comparison with my 3 days doing Java, because they had all these built-in functions. They had all this stuff that was very, not self-explanatory, but very easily comprehensible, where you could tell, like, based on the name of the function, what it did, or if you had any questions, it was super simple to look it up in the function thing and in the elementary introduction book. And so through that, I really got into coding. And when it came to the end of the year for our final class projects, I thought doing something with Mathematica would be a super cool way to really explore it and get more into it. And thus, my adventure in Mathematica began. My partner and I decided to be a little more creative and make it harder on ourselves. So instead of finding a problem in our textbook, we decided to make ourselves a problem. And we used Mathematica to code this lovely little candy land we have up here. And we used all kinds of surfaces we found and all kinds of mesh functions and color functions to make it look really nice. And then we used our calculus knowledge from in class to find gradients, contours, and all kinds of stuff for this little plot. And through that, I learned a lot more about Mathematica and the inner workings, how syntax worked, that kind of stuff. And going into that project, taking on building this Candyland with very, very little Mathematica experience was very difficult, but also very fun to see how you could go into it knowing nothing and learn so much just by testing it out, going through the elementary introduction, the documentation center, and all that. And through that, I got even more into it, and I thought, I really want to continue on with this. Mathematica seems super fun and interesting. And so when Ms. Brown approached us with the option to do a summer program with Augment software, I thought that would be a very fun way to continue on and to learn more. And so we got connected with Eric. We did a lot more in the elementary introduction book and learned we started from the bottom, the very basics of Mathematica and the inner workings, all kinds of stuff like that. And he taught us more about computational thinking and how to use the documentation center and all kinds of stuff just to figure out how to solve a problem even if you know nothing about the functions that you would need to solve it. And so through that, when we went into advanced topics, which is our projects-based Mathematica class at our school, through that, all of my work with Augment carried with me. And so when we went to the beginning of the year and we're learning the very basics of Mathematica over again for people who don't have any experience with it, it was very helpful to be like, oh, even though I only started this a few months ago, I still am able to help others who are brand new at this. And just seeing the amount of growth and knowledge that I had gained over a few months doing just a few projects was a very interesting comparison with a lot of other languages and projects and things that I'd taken on because it was so easy to understand and to get better at. And thus, I began helping other students in the class with their projects when they were having some trouble, helping them debug, find a bracket here and there. And then when she approached us with the opportunity to help out with a computational thinking club at school, I thought that would be a great opportunity to help other students. And so we're there in the class helping other students, and after school in the club, we're helping people who have zero Mathematica experience. We sit with them, we help make sure that they can keep up with everything in the presentation, answer any questions they have. And it's just incredible to go completely full circle in probably about 8 months from sitting in the Computational Thinking Club knowing nothing, doing one of her activities, to being there, helping her run the activities, helping new students with their first introductions to Mathematica, and then creating our own notebooks and interactive projects to do. So, yes, and we'll turn it back over to Ms. Brown to discuss our future plans for the club.
Yeah, so I've got lots of ideas, and of course, coming to a conference like this always just means more ideas. But one of the things we want to do is continue to advertise and recruit students throughout the year. It doesn't have to be like if you miss the boat in the first 2 weeks, you can't join us. We want to continue to develop new activities. I want to get more student-led work, so it's less of me doing the instruction and more of the students. Continue doing these computational conversations. Those were some of our most fun and interesting moments last year. There's additional Wolfram resources I want to explore, computational thinking initiatives resources, the Wolfram challenges, Wolfram U, the notebook archive, which could also be a great place for students to publish and share their own work with the world. And continue working with the elementary introduction book. I wanted to continue developing the future student leaders, so when these fine students graduate, I'm not starting from scratch next year. That's one of the challenges, certainly in an educational setting, is making sure you have that continuity. So go ahead to the next slide. So if you are interested in seeing a little bit more about what we're doing, or you're curious about all these notebooks and things, these images that are coming up, they are from notebooks on our website. It's abbeymath.com/CT for computational thinking. The Computational Thinking Initiatives website has additional resources if you're thinking of something you might want to start up in your own environment. Continue using the text, and even some of the articles that Stephen Wolfram has published recently about computational thinking on his blog have been really kind of motivating and guiding in terms of this idea of what is computational thinking and what are these essays, and having the students read them and see some of the examples that he's presented there has really helped us kind of get things rolling as well. So I think we have a couple minutes for some additional questions, but I do want to thank everybody for coming in and sharing your time with our presentation today, and we'll be around this afternoon and tomorrow as well. So thank you very much.